Hello everyone. Today I'm going to teach you all how to do basic planetary imaging processing. Basically for planetary imaging, we have three main softwares that we're going to use. The first one that's open here is called PIPP, Planetary Imaging Pre-Processing. This will help in the pre-processing part of the process. Then the second software that we use is called RegiStax. RegiStax is a software that we use for stacking an image, and this will help us in some basic processing like sharpening and RGB alignment. And then we have GIMP. GIMP is essentially kind of free Photoshop that helps us in post processing the image that we've taken. Alright. First off, we'll start by PIP. In PIP, essentially, what we do is once how planetary imaging basically works is by taking videos of the source or of the planet, taking short videos, and then taking the frames from those videos and stacking them to get an image. One very major technique used in planetary imaging is called lucky imaging. So, what lucky imaging basically is that we take short 60 to 90-second videos of a target in the sky at a very high frame rate. So, this helps us in avoiding atmospheric blur, which is essentially that due to heat and wind and a lot of other factors, the atmosphere essentially kind of moves or is not still, right? Air and all of that, all of those factors. That what that movement basically does is ruin some of our frames in our videos. So what lucky imaging basically is that when we take short videos at very high frame rate, we try to get frames to try to get essentially lucky enough to get still atmospheric frames or still clear clear frames. That's why the name lucky imaging is given to it, since it's getting lucky with the amount of frames that are very clear. Short and high frame rate, high frame rate essentially helps us to get increases our chances essentially of getting clearer frames in the video. So the first step that we use in PIP is we use PIP to essentially extract the frames from the video we've taken. So to use PIP, we'll go to File here, and we'll add source file. Then we'll go to our, yeah, and we'll take a video here and we'll open it up. So this will, the PIP output frame window is basically essentially just one frame of the video as an like an example frame. So here you can see that it's added a file name. It shows us the type of file, the number of frames, the frame rate at which it's taken, and the file size and directory. Here at the bottom you can see some options which we try to trick is planetary. If you're doing planetary imaging, ISS imaging, solar and lunar close up, or full solar and lunar imaging. So like if you look planetary here, yeah. So after that, we have some pre-processing options that are given here. Input options, we don't usually need to play around with these. For processing, as you can see, we have frame stabilization mode since it's an object of planetary. So what this will do is that, as you can see in the original video, which I'll show you. So in the original video, here we can see that the image is essentially very like the video is not still in a sense. If it opens, yeah, you can see it moves a lot. So what PIP basically does is that it will reduce this movement and essentially just keep the target still in the video. So this helps us in getting a clean video essentially. Um, so that is what frame stabilization does. Object detection is basically it takes a certain brightness of the image, and then it only detects the image above the certain brightness level. So as you can see here, that minimum object size and threshold is basically brightness. So intensity of the pixel essentially. So once we increase and play around with these, if we detect threshold, ideally it should only detect the planet and nothing else. So yeah, you can see here the planet and two, three spots that might be due to sensors and dust and all. But yeah, it mainly only detects the planet, and that's what helps us in object detection, then centering object in each frame, cropping the video to a desired length, and that's all of like personal preferences. As for quality, what we can do in PIP is a pretty good thing is that we can enable quality estimation. So what this basically does is that it allows us to keep the best quality frames. So ideally, you would want percentages of frames, and you can choose the best 75 or best 50% frames. What this basically means is that it will keep the 75 clearest frames and the best frames ideally, which it detects through its algorithm. After this, we have our output options. Animation, we don't need to play around with these. Output options, we have a different output formats. So AVI and SIR are video formats. AVI is a high quality video format, whereas SIR is a format that is used. Um, it's used in astronomical videography essentially. TIFF and FITs are raw image formats that help us in like that contain all of the information, and data is essentially not lost in TIFF and FITs format, whereas in PNG data is lost to a certain extent. And we do not want that, we want maximum data. So ideally while using outputs, we either use AVS or TIFF and or FITs, depending on a person preference. So after we're done with this, we press do processing and it will start processing the frames. I've already done this part on my laptop, so I'm not going to do it. So let's move on to the next software after this, which is RegiStax. So once you get your yeah, once you get each frame in your after your PIP, what you'd want to do is that you'd want to import it in RegiStax. So how you do that is by going to select, go into your directory and choosing the file with the frames and choosing all of the frames. So stacking is a process that takes a decent amount of time. So including it in this video would not be very helpful. So I'm just gonna directly put in the stack file. So this says stretch intensity levels. Now what does this mean is that sometimes after a stacked image you might get a after stacking you might get an image which is too dim or too dim to your liking or too bright to your liking. So what stretch intensity level does is that it stretches the it essentially alters the brightness of each pixel, making it more visible. So if it's something dim, it will increase the brightness a bit. If it's very bright, it will dim it a bit. So that is what it is. Intensity levels are essentially like the brightness of each pixel. So we have pretty good data here. So I would not want RegiStax to do any changes on its own. I'd rather do them myself. So I press no here. Right. So now you can see that we have a stacked image. Um, yeah, before we move on to this, I'll just give a small explanation on how stacking works. So essentially, what you do is that after you got all of your frames, you'd get an option here, which is align. So what this basically does is that RegiStax will set certain align points on your image, will be like red squares that you can see. So it takes one frame, one reference frame, and it will set certain align points on this image. Then after it sets those align points in an image, it will compare those align points to the rest of the frames that we've added to RegiStax and use those align points as points onto which the next image should be stacked. So what this basically does is that this adjusts for misalignment that might happen in stacking, and so that the images are directly one on top of each other. So yeah, after you do stacking, you'd put in your stacked image in this, and you'd be in the wavelet tab. So on the wavelet tab, first thing that we want to do is RGB align. So RGB alignment is basically that due to atmospheric dispersion, the red, the blue, and the green wavelengths essentially get shifted a bit. So RGB alignment tool essentially helps us in getting all of those wavelengths together and one on top of each other, so that that helps in discoloration of the image. So RGB align is not the only tool that helps us in this. We have to use it alongside RGB balance as well. So yeah, I'd go to show a full image because I couldn't see the image here. The green box, we want the full planet on this and not only a part, full planet inside this and not only a part of the planet, so that we can see the software can see the data of the full planet. So after we have the green box covering the full planet, we'd go to estimate, and you can see in the bottom left, it's searching for red and then blue and then green. That's the progress bar. Yeah, blue and then yeah, done. So you can't see a lot of changes here because the stacking data that we use, the data that we use was pretty good. So it didn't need a lot of RGB alignment as such, but it will need some RGB balance, which is what we're gonna do next. So RGB balance essentially, as you can see, that in this graph, this x-axis essentially represents tonal balance, and this is just a histogram graph, which I'll show here. Yeah, so you can see this is the same. So the x-axis here basically represents the tonal value of a pixel. So essentially from very dark to very bright. So black will be the tonal value to white. So you can just see that the blue pixels, and this is the number of pixels on the y-axis. So you can see a lot of pixels on the y-axis are very dim, right? They're towards a darker tonal value, whereas red and green are sufficiently spread out. So that results in this greenish looking image, as you can see here. Not a lot of blue. Essentially, you can just see a lot of greenish image. So ideally, what we want is that this blue part to the blue pixels to stretchen out a bit, give us some brighter tonal values as well to give this a more natural look. So you can use these sliders to do that as well, but to maintain maximum accuracy and precision, I'd rather use the auto balance tool in RegiStax, which does it themselves using an algorithm. So I press on auto balance, and you can see that this was the previous image, and this is the full image that you can see after that, right? This is the balanced image, RGB balanced image, and this is the previous image. So you can see that after I press auto balance, only half of the image has been processed. So that is because the GStack has chosen only this area as a processing area. Now that is not something that we have to worry about right now. RegiStax gives us an option to choose the processing area that we can do it in settings here. So settings, processing area, yeah, settings processing area. So you can have it at 512 or whatever. So having a low processing area essentially helps us in it will help you in faster functions like these functions that have been done here. If you have a slower computer, it will do it faster for you. So that saves your time. So, and don't worry that your final image will not be like this. After you're done with everything, you can just press do all and it will do it to the full image. So that just helps us in saving time while doing these functions. And then once you're satisfied with the result, you can just do it to the full image. So yeah, you can see that it's given us a more natural look here. So yeah, I am pretty happy with that. So I'll just get rid of RGB balance now. So now here we can also manually adjust the tonal value. So you can see that if I put this to the left, it gets brighter. Yeah. If I put it to the right, it will get dim. Right? More green. You can see. So I'll reset it where it was. How much you liked it because I liked this much. I don't think I need more changes here. So yeah, you get rid of that now. Next, cropping we don't need it, and other than that, you can use your resizing image, and these other stacks you don't really need right now. So let's come back to wavelets. Now, as you can see here on the image, it's a little blurred, you could say, a little smooth, right? It's not bringing out most of the details of the cloud here, for example. So what we do is sharpen the image. So what RegiStax essentially does with its wavelets function, sorry, what it basically does is that it essentially slices the image into six independent layers that we can individually and independently denoise and sharpen. So you can see here on the left hand side we have layer 1, layer 2, layer 3, layer 4, layer 5, layer 6. So these are six layers that RegiStax allows us to independently sharpen and denoise without affecting each other. So here we can see that the wavelet scheme is linear and dyadic. So dyadic essentially affects 2 raised to n times the pixels that linear does. So if I go to layer 1 and press the preview, you can see the amount of green pixels and red pixels. So what layer 1 basically does is that it affects and sharpens the amount of green pixels here and not the red pixels. So you can keep going down and you can see that you might think that, oh, the pixels are overlapping, so how is it independent? It's essentially, think of it as the image being cut horizontally, so like a sandwich essentially, and each layer is each part of the sandwich, right? So there will be overlapping things, but it's technically not it is independent, but it's still over each other. if that makes sense. Yeah. So what diadetic basically does is that it affects 2 raised to n times the pixels that linear does. So the layer 1 for linear will be like x pixels, so diadetic will be 2 raised to x pixels. So like let's say here will be 2 times the pixels, here will be 4 times the pixels, here will be 8 times the pixels, here will be 16 and so on, 16, 32, 64. So 2 raised to n, which is n is the layer number. So if I go to diadetic here, for example, and actually the previews, you'll see that there are more pixels being involved. You can see here it's very visible, right? So this is because it affects 2 raised to n times the amount of pixels. So here it's only twice, so you can't see much of a change. 8, you can see some, and eventually once you go to 64, you can really see the change here, right? Whereas in linear, it only affects these many pixels. So 64 times these many pixels is what diadetic affects. All right. So then now let's go to our initial layer and step increment is essentially the sensitivity of the first layer. So let's keep it at 1 for now. Wavelet filters, Gaussian or default. Gaussian is essentially what I just explained, the 6-layer splitting algorithm that RegiStax has within itself. It is it is the recent algorithm that RegiStax has, and that is what everyone uses. Default is the older algorithm, which essentially does not help in splitting. Linked wavelets essentially is that the first layer will affect the second layer and so on in a small way. So let's start with the sharpening process. So essentially, this slider is the amount of changes, the changes that we do here, the percentage of how much will that affect layer one. So if I put it all the way to the right, as a start, the changes here will be applied 100% to the image. So you can see already the image has already been sharpened a little bit, and that's because our sharpen is at 0.1. So I want to increase that. So I'll keep it to, let's say, this much, right? 0.13. And I'd increase the denoise a little bit because you can start seeing some noise here. So let's say I increase this a bit, and then I increase the denoise a bit. So yeah, you can see that the image has slightly been sharpened with less noise. Now, if I want this layer one effect to be around 50 to 60% of the image of layer one, this effect, so I just decrease the slider here to, let's say, 55.2, and this will affect layer one. 55.2% of this effect will only be applied on layer one, for example. Same thing with layer two. I'll increase it a little bit, and then you just increase the sharpening. So 0.5, yeah, okay, that's fine. So we essentially don't play around with layer 3, 4, 5, 6 a lot because, as I said, that they are vertical sandwiches in a way. So affecting the first two layers and then compounding that effect will increase the sensitivity. So will increase the effect essentially. So by the time we reach the sixth layer or the fifth layer, the sensitivity of each change has increased to a high extent, which might make the image look very over sharpened or or denoised. So to avoid that, we just play around with 1 and 2 to the extent we can, and let 3, 4, 5, and 6 be as it is, right? So once you're happy with a combination that you've used here, you can go and save it under the Save Scheme option. So next time you do planetary imaging, you can quickly just go to load scheme and do it, right? So I have a scheme node here, so I'll use that to show you how it's done. You go to load scheme, you go here, you just go to open. So yeah, you can see that I've used this scheme here, and it has sharpened the image quite a bit right now. Yeah. So brought out a lot of details in the image as well. So after this, we'll go to save image. First, we do all because as you can see, the full image is not in the processing area. So we go to do all, and yeah. Before that, let's use linked wavelets. Linked wavelets essentially we'd use the same process as what I explained, but we need to realize that in linked wavelets, layer 2 also gets extremely sensitive because that all of the layers have a small effect on each other essentially, right? So layer 2 also gets extremely sensitive. So I'd rather avoid linked wavelets. So I'll just show you how it looks. Reset wavelets. Yeah, so I'd use linked wavelets here now. If I move the slider all the way to the right without doing any changes to the sharpen, we can see that it's already sharpened and increased noise, right? A little bit. Now, if I do the same thing for 2 as well, you can see that the image is completely blown out, and this is because of the increased sensitivity. So here, let's just add some denoise without making any changes here. So zero point 0.5, zero point 0.2, and 2.15. I'm not sure what's happening here. Well, let me just. Let's just do that again then. Sorry. Yeah. Here, let's increase this and yeah. So the image is fully blown out here. Let's just denoise a bit. So let's just go to 0.25. And let's go to zero point 0.5 because we can do a little more on layer 1 than we can on layer 2. So yeah, you can see that we still have a sharpened image here. Let's just, if we lower the sharpening a bit, we'll get probably a clearer image. So the denoise a bit. So yeah, that's how we use link creators as well. It's up to personal preference. It's up to personal preference how we want to use them. I'd prefer not using it, but yeah, each to its own. So after we have done with this, we go to do all and do the processing on the full image, and then we just go to save image and save it in the directory you want. Okay, yeah, save. After we do this, let's go to GIMP. GIMP is the post-processing software that we use. So yeah, I'll open GIMP. GIMP is used for basic color editing. It is not really necessary. It's up to personal preference. It's like a kind of Photoshop that you use for yeah personal. It's like a free photo, open source Photoshop essentially. Okay, so yeah, I'd open my Jupyter. Great. So once I have my Jupyter here, you can use basic stuff like cropping. When you want to crop the image, you just press that tool, hold left click, choose your frame that you want to do, and press enter. Like this, press enter. Yeah, so it's cropped the image. As you can see, this was the original frame. This is the new frame. Here, mostly what we do is some color editing. So just mostly hue saturation. This is very useful in singular editing, singular color saturation. So planets like Mars and all, where you want more red, you can just choose the red. Red color and adjust its saturation instead of use adjusting saturation of all the colors, right? So as you can see, there's some blue here, blue hue here, which I don't really like. So I'm just gonna choose blue and decrease the saturation a bit. Um, let's get cyan as well, shade of blue. So yeah, now that's gotten rid of that. So I'm pretty happy with this image as a whole, but you can play around with the saturation, some brightness contrast that you want to imply to it. Like I don't think it's needed in this image right now, but some brightness contrast is up to personal preference. So if you want to play around with this, you definitely can. I wouldn't recommend more options in this because planetary imaging does not require such high levels of editing as deep space would. So yeah, that's about it. That is the session we hold on planetary image processing. Yeah, if you have any doubts, you can reach out to us. And yeah, that is pretty much it. It's a very simple procedure that is used. We'd have a basic workflow, which is shoot a video of the image. After we shoot a video, we'd go to PIPP to extract the frames. After we extract the frames, we go to RegiStax for stacking the frames and sharpening and some processing on the frames. And then we'd go to GIMP for post processing, which involves color adjustment and shadow highlights, brightness contrast, etc. So that is the basic workflow of planetary imaging. I hope you enjoy. Thank you.